Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey there, Herman and Corn. So recently, with all the stuff going on in our apartment, I've been buying a few things from the internet to kind of get kitted out for the next phase of our life. And one thing that I ordered from the internet that I wanted to have for some time is a GPS tracker for our car. It sounds kind of a little bit sketchy. We've talked about surveillance tech before, and that's certainly one reason that people want to know where their car is. But a more common reason, I would think, is just the knowing where you parked and knowing that your car has not been stolen. And those are the two reasons that I picked this up for. When you look at them on whatever website you're going to buy them on, you need two things. So you need the actual tracker device. It takes a SIM card. It goes into your car. Some of them are battery powered. Some connect to the car's internal power supply. And then you're going to need a data SIM card in order to occasionally report to some server. You can do self-hosted TrackR, a great open source app for position tracking, or you can use a proprietary solution. But either way, the thing's going to need some data. It's going to need GPS, and it just sends these very periodic pings. It's a very light data application. You'll commonly see when you're buying these devices that they're definitely not 5G. Often they're going as far back as 2G, and it's common to see them in 3 and 4G. I went for a 4G device because Israel is in the process of already deprecating the older GSM networks. And we've talked before about Israel being kind of a unique case in that it manages the RF spectrum very, very proactively and carefully. So I guess if there's 2G, I think 2G's already been sunset here. And I know in the US that AT&T and Verizon had a major sunsetting program. You might read about this in the news and you think, well, who on earth is still using 2G and 3G in 2026? And the answer is actually a lot of IoT devices and trackers, just like the ones that I mentioned. So Herman and Corn, I'd love to talk today about these older GSM networks. And another very interesting one is narrowband IoT, or NB-IoT. Israel has one deployment, I believe, with Pelephone, and these are useful too. So the question really is, we're talking about the RF spectrum, and it's actually quite it's a topic of importance that countries, you might think, what's the harm in just leaving old 2G gear sitting on the antenna, so long as it's on different frequencies? But that's the point. It's cleaning out the old stuff to make room for the new. So going forward, let's just think about, car trackers. People also use GPS trackers to know that their kids are safe. It's a whole world out there of people relying upon these very low data GPS-backed solutions. And 5G offers way more bandwidth than these need. What is the future? Do you think it is going to be maybe just engineering on the 5G that we all use and just building a low-powered version? NB-IoT, the old networks. What's the future looking like? Or what will the future look like, do you think, Herman and Corn, for the many, many applications for GPS tracking and the kind of connectivity they require?
Herman, I saw Daniel unboxing that GPS tracker in the kitchen this morning, and it really struck me how much of a hardware time capsule those things are. You look at the specs and it feels like you're stepping back into 2007. It is February of 2026. We have commercial space tourism and AI that can write symphonies. Yet here is a brand new piece of plastic that looks like it belongs in a museum.
It really is a strange little niche of the tech world. Herman Poppleberry here, by the way, and yeah, Daniel's prompt is spot on because we are in the middle of this massive, invisible infrastructure overhaul. It is like trying to renovate a skyscraper while everyone is still living in it. Or, more accurately, it is like tearing down the old wooden bridge while there are still thousands of cars trying to drive across it.
It is the great sunsetting. We have talked about the Internet of Things before, specifically back in episode 309 when we were looking at the protocol alphabet soup, but this feels different. This is about the actual physical airwaves. Daniel noticed that his tracker is basically hunting for a signal that, quite literally, was turned off just 48 hours ago, here in Israel.
Exactly. February 1st, 2026 was the official frequency clearance date set by the Ministry of Communications. If Daniel bought a 2G or 3G tracker last week, he effectively bought a very expensive paperweight. To understand why this is such a headache, you have to look at spectrum efficiency and the actual physics of the airwaves. Think of the radio frequency spectrum like land in a crowded city like Jerusalem. Back in the 2G and 3G days, we built these sprawling, one-story buildings. They were great for what they were, they handled voice calls and tiny bits of text data, but they took up a lot of room relative to how many people they could serve.
So 5G is the skyscraper?
Precisely. 5G uses much more sophisticated modulation. It can pack way more data into the same amount of land or spectrum. Carriers want to refarm those old 2G and 3G frequencies because they are sitting on prime real estate. Specifically, those lower frequencies like the 800 and 900 MHz bands are the gold standard. They have incredible range and can pass through walls like they aren't even there. Carriers want those frequencies to give thousands of people high-speed video streaming and low-latency gaming instead of just letting a few thousand old GPS trackers send a tiny ping once an hour.
I get the business logic for the carriers, but for the end user, or for someone like Daniel who just wants to know if his car is still in the parking lot, it feels like a forced upgrade. If the data requirement is so low, why do we need 5G for a GPS tracker? It is like using a semi-truck to deliver a single postage stamp.
That is the perfect analogy, corn. And that is exactly why the transition has been so slow and painful. 2G, especially GSM, which stands for Global System for Mobile Communications, was incredibly robust. It was the first truly digital mobile network, launched all the way back in 1991. For a device that only needs to send a few bytes of data, like a latitude and longitude coordinate, 2G was perfect. It was cheap, the chips were pennies, and the power consumption was minimal. You could slap a 2G module on a shipping pallet and it would work for months on a tiny battery.
But now those networks are gone. In the United States, the shutdown was a long time coming. AT&T and Verizon finished their sunsets years ago, and T-Mobile, which was the final holdout, finally pulled the plug on their 2G network in February of last year, 2025. They even offered free 5G replacement devices to their remaining 2G customers just to get them off the old towers.
It is a global trend, and it is not just about phones. The problem is that there are millions of these dumb devices out there that we don't even think about. We're talking about smart meters in your basement, elevator emergency phones, vending machines, and those little SOS buttons for the elderly. You can't just flip a switch without breaking critical infrastructure. In fact, the Israeli Ministry of Communications actually had to mandate that carriers keep a dedicated 2G slice open specifically for emergency calls until the end of 2028, just to make sure people in older elevators or with legacy medical alerts don't get stranded.
So what is the actual replacement? If 5G is too big for these devices, what replaces the small connectivity of 2G?
This is where it gets interesting. We are seeing two main paths that have finally matured. The first is what we call LTE-M, which stands for Long-Term Evolution for Machines. It is also known as Cat-M1. This is a simplified version of the 4G LTE network we all use on our phones. It is designed specifically for devices that need medium data rates but want very long battery life. It supports mobility, meaning it can hand off from one cell tower to another without dropping the connection, which makes it the absolute best choice for a car tracker.
And the second path is the one Daniel mentioned, right? NB-IoT.
Exactly. NB-IoT, or Narrowband Internet of Things. This is even more stripped down than LTE-M. It uses a tiny slice of bandwidth, only about 180 kilohertz. To put that in perspective, a standard 5G channel can be 100 megahertz wide. NB-IoT is like a tiny straw compared to a massive water main. It is perfect for things that stay in one place, like a smart water meter or a soil sensor on a farm. It has even better indoor penetration than LTE-M, but it doesn't handle handoffs well. If you are moving at 60 miles per hour down a highway, NB-IoT might struggle to keep up.
I like the straw analogy. But if it is so small, what is the benefit? Is it just about the spectrum efficiency you mentioned?
It is about three things: cost, battery, and coverage. Because the bandwidth is so narrow, the chips can be much simpler and cheaper to manufacture. More importantly, these devices can use something called power saving mode and extended discontinuous reception. Basically, the device can go into a deep sleep for days or even weeks, and then wake up just long enough to send its data without having to renegotiate its entire connection with the cell tower. In a world where we want to connect billions of things, we need that efficiency.
That sounds perfect for a GPS tracker. You don't need the car to be talking to the network while it is parked and the engine is off. It just needs to wake up if it senses movement or if you request a location.
Exactly. And the coverage part is key too. Because the signal is so narrow, you can concentrate the power. It is like the difference between a floodlight and a laser pointer. That laser pointer, or the NB-IoT signal, can reach deep into basements or underground parking garages where a standard cell signal might fail. That is a huge deal for a car tracker. If a thief hides your car in a concrete parking structure, a standard 5G phone might lose signal, but an NB-IoT or LTE-M tracker might still be able to scream its location.
Okay, so if these are so great, why was Daniel still finding 2G and 3G trackers for sale? Why did it take until 2026 for this to become the standard?
It was a classic chicken and egg problem, corn. For a long time, the hardware for 2G was just so much cheaper because it had been manufactured in the billions for decades. If you are a small company making GPS trackers, you are going to go with the $5 chip over the $15 chip every time. Plus, the global roaming situation for NB-IoT was a mess for years. 2G worked everywhere. You could take a 2G tracker from London to Jerusalem to New York, and it would just work because GSM was a universal language. NB-IoT required new, specific roaming agreements between carriers that simply didn't exist until recently.
So we were stuck in this loop where manufacturers wouldn't build the devices because the roaming wasn't there, and carriers wouldn't prioritize the roaming because there weren't enough devices.
Exactly. But the sunsetting of the old networks finally forced everyone's hand. By 2024 and 2025, we saw the roaming floodgates open. Now, an LTE-M device can roam across North America and Europe almost as easily as the old 2G ones did. And that brings us to the newest player on the field, 5G RedCap.
RedCap? Like a little hat?
It stands for Reduced Capacity. I know, engineers are great at naming things. But 5G RedCap is basically the Goldilocks of connectivity. It sits right between the high-speed 5G we use for our phones and the ultra-low power NB-IoT. It was introduced in the 3GPP Release 17 standards, and here in 2026 we are seeing it hit the mass market. It is designed for things like high-end wearables, industrial sensors, and advanced automotive tracking.
What makes it better than just sticking with the 4G versions like LTE-M?
It brings those devices into the native 5G ecosystem. That means lower latency, better security, and most importantly, it ensures they won't be sunsetted anytime soon. When you buy a 5G RedCap device, you are essentially future-proofing it for the next 20 years. It also allows the network to handle a much higher density of devices. In a future where every car, every bike, and maybe even every pair of glasses is connected, you need a network that can handle millions of connections per square kilometer. 5G was built for that, 4G was not.
I'm thinking about the second-order effects here. If we successfully move all these low-data devices to NB-IoT or RedCap, what does that actually change for the average person? Besides Daniel's car tracker working better in the underground garage, of course.
It changes the economics of connecting everything. When the cost of the chip drops to $1 and the battery lasts 10 years, you start seeing use cases that were impossible before. Think about smart shipping pallets that track temperature and vibration for 5 years without a charge, or sensors in the soil of every farm that talk to a satellite. It moves us from the Internet of Things, being a buzzword, to it being a silent, invisible utility. But there is a massive flip side to that, corn, the environmental impact.
Right, the electronic waste. If we are bricking millions of 2G and 3G devices, where do they all go?
It is a crisis, honestly. According to the Global E-Waste Monitor, the world generated over 62 million tons of electronic waste in 2022 alone. By 2030, that is projected to hit 82 million tons. These network transitions are a huge contributor to that. We are essentially turning millions of perfectly functional pieces of silicon into garbage because the invisible road they drive on is being torn up. Only about 22% of that waste is actually documented as being recycled. It is a huge argument for modularity in design, where you could maybe just swap out the communication module, but in the world of cheap consumer electronics, that rarely happens.
It is also a security issue though, right? A lot of those older 2G devices had very weak encryption, or none at all. Moving to 5G RedCap or even LTE-M brings much more robust modern security standards to these tiny devices. It is harder to spoof a signal or intercept the data.
That is a great point. 2G was notoriously easy to stingray or intercept using a fake cell tower. For a GPS tracker, that is a pretty big vulnerability if someone wants to track you without your knowledge or jam your signal. The newer protocols are much more resilient. They use mutual authentication, meaning the device and the network both have to prove who they are before they start talking. It makes the whole ecosystem much harder to hack.
So, let's talk about what people should actually look for right now. If someone is in the market for a tracker or any connected device in 2026, how do they avoid buying something that is about to be obsolete?
You have to look at the CAT rating. That stands for category. If you see CAT M1 or CAT NB-1, you are in good shape. Those are the 4G-based IoT standards that will be supported for at least another decade. If you want to be on the absolute cutting edge, look for 5G RedCap or 5G NR Lite.
NR Lite being another name for RedCap?
Yes, New Radio Lite. It is the same thing. It is basically the industry saying, we made 5G, but we made a version that doesn't eat your battery for breakfast. And whatever you do, stay away from anything that mentions GSM, GPRS, HSPA, or 3G. Those are the labels of the past. If you see those on a box in 2026, the manufacturer is likely just trying to clear out old inventory before people realize the networks are gone.
It is interesting how the technology is almost circling back. We started with these very simple, low-power networks. Then we went through this phase of more speed at any cost. And now we are realizing that for the majority of things in the Internet of Things, we actually need to go back to that low-power, high-efficiency mindset, just with modern security and better spectrum use.
It is the maturity of the technology. We are no longer just trying to see how fast we can go, we are trying to see how broad we can go. How many things can we connect reliably and sustainably? That is the real promise of the 5G era, even if the 5G part of it is actually quite slow for these specific devices. And there is one more frontier we haven't even touched on yet, the sky.
You mean satellite-based IoT?
Exactly. This is the biggest change we have seen in the last 2 years. Companies like Starlink have fully rolled out their direct-to-cell service. As of 2025, they have been providing data and IoT connectivity directly to unmodified devices. Imagine a GPS tracker that doesn't care if there is a cell tower nearby because it can send a tiny packet of data directly to a satellite in low Earth orbit. We are already seeing this with the latest smartphones, but scaling that down to a $10 GPS tracker is the next big frontier.
That would be a game changer for theft recovery. You can't hide a car in the desert or a remote area if it has a direct line of sight to the sky. No more dead zones.
Precisely. Starlink already has over 650 of these direct-to-cell satellites in orbit as of January, and they are adding more every month. It is making the whole tower sunsetting problem almost irrelevant for certain use cases. If you are a shipping company tracking containers across the ocean, you don't care about 2G or 5G towers, you just care about the sky.
So, to answer Daniel's question more directly, the future isn't just faster. 5G. It is a more fragmented, specialized version of connectivity. We are going to have the big pipe for our phones and the tiny straw like NB-IoT and RedCap for everything else, with a satellite safety net over the whole thing.
And the transition is mandatory. The old networks are being repurposed. It is like the digital version of urban renewal. It is messy, it creates a lot of waste, but it is the only way to make room for the billions of devices we want to connect in the future. It is a good reminder for all of us to check the specs before we buy anything smart.
Great advice. I hope Daniel kept the receipt for that 2G tracker if that is what he bought. Knowing him, he probably bought 3 different versions just to test the signal strength around the neighborhood. He's basically doing his own field research.
He probably is. And honestly, we need more people like that asking these questions. It is easy to forget that everything we use depends on these massive, expensive networks that are constantly being torn down and rebuilt.
It really is. Well, this has been a fascinating look into the invisible side of our gadgets. If you are listening and you have noticed your older devices starting to act up, or if you have questions about the tech in your own life, we would love to hear from you. You can find us at myweirdprompts.com and use the contact form there.
And if you are enjoying these deep dives, please consider leaving us a review on your favorite podcast app or on Spotify. It really helps other people find the show and keeps us motivated to keep digging into these weird prompts Daniel sends us.
Definitely. A quick rating makes a huge difference. Thanks for joining us for episode 426. We will be back soon with another exploration of the strange and wonderful world of technology.
Until next time, I am Herman Poppleberry.
And I'm Corn. Thanks for listening to My Weird Prompts. We will catch you in the next one.
See ya.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.